So this is going to be 6.6, and we're just going to talk about definitions of trapezoids and kites and some of the rules that they have. I'm not going to do any problems with you guys. It's just going to be mostly definitions because this lesson has lots and lots of definitions. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, one pair. So it's going to be called our bases, and then our other two are going to be called our legs. Okay, and isosceles, well, isosceles means two sides have to be congruent, so I'll have my two pairs of parallel sides, but if I have parallel sides, it doesn't always mean that those two sides are going to be the same, or like the same size. It just means they're parallel. That means they never intersect. Okay, but an isosceles trapezoid, our two legs should be the same size. Okay, so our parallel sides are called our bases, our other two sides are called our legs. An isosceles type is going to have the two legs being the same size. So isosceles trapezoid theorem. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So all of my pairs of angles are congruent. So R and A are congruent, and then T and P are congruent. Okay, parallel lines in a transversal create supplementary. Okay, therefore angle R is a supplement of angle T, because if you look at it, this is a parallel line, this is a parallel line, here's my transversal. Same side interior angles should always be supplementary. And angle R and angle T are supplementary, so they should add to be 180 degrees. That's why they're not congruent, but they are supplementary. So then, likewise, if you look, A and P are also supplementary. Okay, diagonals of an isosceles trapezoid. So isosceles, the two sides are congruent. My two legs are. So if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. If they're congruent, it means they're the same, which means we can set them equal to each other. The reverse of it, if I have congruent diagonals, then I also have an isosceles trapezoid. Mid-segment of a trapezoid. So mid-segment's that weird little segment in here that last time we said was always half of whatever the big segment is. Okay, so this time it's a segment that joins the midpoints of the legs of a trapezoid. Okay, so the mid-segment theorem, if a quadrilateral is a trapezoid, then the mid-segment is parallel to the bases, so the bases being the two sides that are parallel, the two sides that are parallel, and the length of the mid-segment is half of the sum of the length of the bases. So, I don't know why this text got all weird. So half of the sum of the length of the bases. Well, my bases in this situation are 6 and 10, so sum means to add them. And then we're going to take half of it to figure out my mid-segment. So 6 plus 10 is 16. Half of that is 8. So my mid-segment is 8. And you can actually see that it should be longer than 6, but smaller than 10. So you're going to add your two bases, cut it in half. A kite, a quadrilateral with two pairs of congruent consecutive sides. So we have those two sides being congruent and these two sides being congruent. And no congruent opposite sides. So these two sides are not congruent to each other, so this one and this one. And these two diagonal ones, the opposite ones, are also not congruent to each other, which is why it is a kite. The non-vertex angles are also congruent. Okay, so if you look at my picture here, these angles will be congruent, and you'll see that in a later picture. Angle bisectors of a kite. Well, an angle bisector cuts an angle in half and makes two smaller congruent angles. So if the quadrilateral of a kite, then if the quadrilateral is a kite, then the vertex angles, so my angles that are on the outside here, are bisected by a diagonal. Okay, so you can see how my angles are being bisected by this diagonal here. And when they're bisected, they are cut in half, which makes two smaller congruent angles. Okay, theorem, diagonals of a kite. So if a quadrilateral is a kite, then its diagonals are perpendicular. So if I have my diagonal here and my diagonal here, it creates a perpendicular line. So in class, we're going to be doing these definitions where you guys are going to do some more fill in the blank. And then we will do more mathematical work and problems. But I want you to make sure you get all these definitions down so we don't have to keep writing them over and over again, because it's a lot and lot of vocab.